And dear students, in this video you will learn about the storage classes in C. So generally how we can define the variables. If you will see how we can define the variable, first of all we need to specify the data type. So first of all this is an integer data type, and then we define the variable like a comma b comma c and so on. So that is called variable declaration. So by this way we can declare the variable in C language. Similarly, if we want to declare the float type variables, we need to define the float data type, then we need to define the variables here. So suppose this is your x, y and z. So I have defined here the three variables of type float. And if you want to define the character variables, how we can define with the help of character, then we can define here the variable name. So we can take it here like this is x. So this is a character variable. Now what are the properties of these variables? If you will see, if we are declaring this a, b and c of type integer, that means all these variables a, b, c will take 2 byte space in the memory, because integer takes 2 byte memory space in case of a compiler, in case of a C compiler. So a will take 2 byte space, b will take 2 byte space, and c will take 2 byte space. One more thing, one property of this data type is to define the range of a variable. So in this case the range of this variable a would be -32768 to +32767. Similarly, for this b, the range would be same, that means -32768 to +32767. Now if we will consider this case float, so in case of this float data type, this float data type takes 4 byte space in the memory. So this x will take 4 byte space, y will take 4 byte space, and z will take 4 byte space in the memory. But how much long it will take, that means how much range it will take to define the float type variables. So the range of this float type is -3.4 e, that is your exponential 38, to plus 3.4 e 38. So that is the range of the floating point numbers that we can store in these variables x, y and z. And this character, we will talk about this character data type. So character type is taking only the one byte memory space. So x can contain only the characters values. Now what are the range for this character type variables? When we will see about this character type variables, so it is the range is -128 to plus 127. So that is the range of this character data type. When we will talk about the format specifier related to these data types, suppose this is your integer variable a, b and c. So for this defining or for printing the particular variable values, we use the format specifier, and the format specifier for integer is %d, or we can use %i. Similarly, for the floating type, we can use %f, that is your format specifier for the float, and for the character we can use format specifier, that is your %c. So by this way we can define the variables in case of a C language. Now we were talking about storage classes. So what is the storage classes? So generally storage classes, we define the variables not fully. When we talk about defining these variables, that means we are not defining it in a fully way. So how we can define? Generally storage class are used to fully define the variables. Fully define the variable means, that means in this case we not only define the type, but we will also define the storage classes. So there are number of storage classes in case of a C language, and generally we have 4 types of storage classes, that is your automatic storage class, register storage class, static storage class and external storage class. So let us start with the storage class definition. So generally why we use this storage class? That is used to fully define the variable. Now, what it means fully define the variable? Generally, we can store these variables in either two of the locations. That is, we have the two locations generally in case of memory when we will talk about the storing of these variables. The first one location is called memory, and generally when we will talk about memory, that is your primary memory, or you can say that that is your RAM, read write memory. Second, the location where the variable can be stored is CPU registers. Now, what are the CPU registers? When we will talk about the CPU registers, we have generally number of type of CPU registers are there, and it is generally 8 registers in the CPUs, and there is special kind of a register which is called accumulator. So generally this CPU register can be also used for storing the variables. So now when we will talk about this variable storage class, so what the variable storage class tell? First one, where the variable would be stored. Where the variable would be stored. Second, what would be the default initial value of the variable. Third one, what is the scope of the variable? That means in which function the value of the variable would be available. And the fourth one, what is the life of the variable? That means how long variable would be available. So variable storage, that means variable storage class tell us about first one, that is your where the variable would be stored. Now the variable may be stored at either of the two locations. That means it may be either stored at the memory. Second, it may be either stored at CPU registers. Now the second variable storage class tells us initial value of the variable. Initial value of the variable. And third one, what is the scope of the variable? That is in which functions the value of the variable would be available. And the last one, that is what is the life of the variable. Life of the variable, how long variable would be available. So these are the properties of the storage class variable generally tells. Now come to the storage classes types. So generally we have the 4 types of the storage classes. There are 4 storage classes. The first one is automatic storage class. Second one is called register storage class. Third one is static storage class. And last one, that is your fourth one, is external storage class. So generally we have 4 types of storage classes that generally we use. And now come to the first one, that is your automatic storage class. So now what are the differences between these storage classes? So we will see it here one by one. So this is your first storage class we are discussing about, that is your automatic storage class. Now they are differ with each others with the help of, we can distinguish in between these with the help of some properties. So first property of this all of the storage class is called default storage. That is called default storage. Now we have the generally 2 default storage. The first one is your memory and second is your CPU register. So in case of a automatic storage class, the default storage is our memory. And when we will talk about this memory, that means we are talking about the primary memory. Second by which we can distinguish between the classes is, second is default initial value. So this is default initial value. Now what is the default initial value? In this case, that is your an unpredictable value. An unpredictable value. or you can say that unpredictable means garbage value, you can say that. So this is your garbage value. Now what is this garbage value? There is some location that it can take, so that is called garbage value or unpredictable value. Now come to the third one, property by which we can distinguish about these classes, that is third one is scope. So now what is the scope in case of this automatic storage class? Local to the block, that means where this variable is declared in the block, so that will be the scope for this variable. Like you are declaring the particular variable in a function, so that is binded to the that function only, so it is called local to the block here. Now the last one property by which we can distinguish between the all these storage classes, and this is your life. So this is your life. If we will talk about this lifetime, the lifetime of the variable in case of a automatic storage class, that is till the control remains within the block. That means when the block we have defined and in which we have variable is defined, so the whenever the control will be there for this block, then the lifetime of this will be your variable, automatic storage class variable. So we will see here the example of this with the help of a program, and we can write a program in C language by using the automatic storage class. So let us see how we can make this program with the help of a storage class. So first of all we need to go to this code blocks. So go to this code block and we can write here the program. So this is your hash include stdio.h. This is our header file. Now I'm just going to define the main function. So this is our void main, and then we can define the scope. So this is the scope of the main function where we want to define the automatic storage class. So there is this keyword, that is your auto, we can use for defining the automatic storage class. So this is your auto, we have taken here the auto keyword. Then I am going to define a variable of integer type. So this is your integer. Now I am going to define I comma j variable. Now if I want to just print, so this printf statement we will use. In this I am just going to pass %d and then again %d, then we can define comma I and comma j. I can also put here the /n for distinguishing between these variables values. So this is your /n. So when we will print this one, so you can just execute this program, just click on the save and then execute this program. So you can see that this is the output. So this is the output is 0 and 16. Now we will see the properties and we will discuss about the automatic storage class property. So by this output we can measure, how the automatic storage class works. The first property was default storage. Default storage means in this case where we have written the program, so this program is storing these variables I and j into the memory. So default storage is memory in case of a automatic storage class. Second, default initial value, and as I have already discussed about the default initial value in case of a automatic storage class is an unpredictable value. So you can see it's the output in this case is unpredictable value. So in this case in unpredictable value is 0 and 16. Now third one, the scope of these variables I and j which we have declared with the help of auto variable. So the scope is local to the block. So local to the block means the block is from this main function starting bracket and closing bracket. So that is the scope for these variables where we have defined this variable. Now what is the life? Life means the life is again within the scope of this main function. So when you will run or execute this program, you may get the different values because since the garbage values are unpredictable in this case. But the one thing that we need to observe is here we are using the keyword auto, not the automatic, for defining the automatic storage class. So that was a simple program related to the automatic storage class. Now we are moving on to this our concept, second concept, that means second type of storage class, and which is storage class is register storage class. So this is register storage class. Now we will see about the properties of these register storage class. The first property, or you can see that the feature of the register storage class variable are, the first one is storage. So default storage, when we are talking about this storage, default storage is CPU registers, as the name suggests, register storage class. So the variables we will define using the register storage class always will be stored at the CPU registers. Now second, that is your default value, or you can say that default initial value. So this is the default initial value will be your garbage value again. So we cannot predict that value here, garbage value. Now third one feature is scope. Then we will discuss about the scope in case of a register storage class, that is your again local to the block in which the variable is defined. Now the another one, that is last one, that is a lifetime, you can say, or that is you can say that is a life of this variable. So till the control, the same, till the control remains within the block in which the variable is defined. In which the variable is defined. So these are the four features of this register storage class. Now we will see the program here with the help of this register storage class. So let us go back to our code blocks. Generally, when we will talk about this register storage class, a value is stored in the CPU register, and that can be only accessed faster than the one that is stored in the memory. So when we are using this register storage class, the fetching of these variable values is faster than the automatic storage class. So let us see the example. So I'm just going to write the program here. So again, this is your include stdi.h, that is your header file. Now I'm going to declare here the variables with the help of register. So this is your register keyword, then integer I, then I am going to use the for loop here. So this is your for loop for I equal to 1, and then I is less than equal to 10 and I plus plus. So this is the scope of the for loop where I am just going to print. So this is your printf statement. In this printf statement, I'm just going to write /n, that is your %d and comma I. So this, through this I means that is your register. So one thing that need to be observed here is that register is our keyword here. So register is our keyword by which we are going to declare this I variable. So this I of the register storage class, we cannot be sure about the value would be stored in the CPU register because the number of CPU registers are there. So we cannot find out that particular register in this case. So if you use the register storage class, then how we can store that with the help of this register, CPU registers. Now I'm just going to execute this program, and it takes the default initial value will be garbage value. So I'm going to execute this program. When we will execute, you can see the output. It is taking 1 2 3 4 5 6 7 8 9 10. What we are going to print here, we are going to print here 1 2 3 4 5 6 7 8 9 10. So this I is printing the value from 1 to 10. When we will print directly the I, so it will just print the garbage value. So let us see how we can see the output in this case. I'm just going to omitting this for loop here. So this is for loop I have removed from there. Now I'm just going to print this I value. So just execute it, and you can see that garbage value is here. So 8 it is printing. So this is your garbage value in this case. Now come to the next type of storage class, and third type of storage class is our static storage class. This is static storage class. Now again we distinguish it with the help of features. So first feature, that is your storage. So in this case default storage is memory, in this case memory, and second, that is your default initial value. So you can say it right directly, it is a initial value or default value you can write. So default value. So in this case default value is 0. 0 means it will always print, when we will go to print this variable static storage, it will print 0 directly. It will not print the garbage value in this case. Now third one by which we can distinguish it, that is your scope. So scope is again local to the block in which the variable is defined, local to the block where the variable is defined. Now the last one, fourth one, that is your life. So in this case life, again value of the variable persists between the function call. Value of the variable persists between different function call. So this was the last feature of this static storage class. So now let us see the program on this static storage class. So this is our hash include stdio.h, this is your header file. Now this is our main function. So before defining a particular function, I just need to be declare a particular variable. For defining a particular variable, so I'm just going to declare a function here. So this is void, and I am defining a function here, that is your increment. So increment is the function, that is your user defined function. Now in this case main function I am defining. In this main function I am just going to call this function, that is your increment. Increment function is calling. So this is called function calling. As you know, this is called function calling, and this is called function prototype declaration. So this is function prototype declaration, which tells to the compiler which type of function we are going to use and what is the function name. So in our case the function name is user defined function is increment. So this is first time we are going to call this function, that is your increment. Now again I am going to call this function, that is your increment, and again going to call third times, that is your increment. So this is 3 times we have called the function. Now we are going to define this function. So this is our function which have the return type is void, that is it is not returning anything. Now this is increment. Now the braces we have defined the scope. I'm just going to declare here the static storage class variable. So before defining the static storage class, I just want to show you the difference generally when you will get in case of a auto as well as in case of a static. So I'm just using firstly the auto. So this is your auto, and then I'm defining int I equal to 2, and I'm just going to print this value. So this is your printf. In this printf statement I am printing %d and then comma I, and going to increment in this case. So I equal to I plus 1. Now when we will execute this program, so click on the save button and then execute this program. So you will see the output is 2, 2 and 2. So actually we have called this function 3 times: increment, increment and then increment. So 3 times we are calling. So first of all, auto will the increment function will be called. So control will jump to this function increment, where we have declared an automatic storage class. In this automatic storage class we have initialized I equal to 2. It is printing 2 here. Then we are going to increase I equal to I plus 1. So it should increase I to the value 3, but it is not so. Why it is not so? It is incrementing here, but the difference is that the scope of this auto is what? In case of a auto, the scope is local to the block in which the variable is defined. So we have defined this variable I equal to 2 with the help of automatic storage class, and that is local to this block. The local to the block means the localist block is from this increment is this scope. That means this left braces and then right braces. So when the control will jump over to this increment to back main function, the default value will be stored as a I equal to 2. So once it will print here, value will be 2. First time we are calling increment, so the control will jump to this one. It will initialize I equal to 2. So it will print 2. Then it will increase the value 3. But when it will goes out of this scope, the value would be changed. Value would be default. And then second time when the increment will be called, again it will initialize with the I equal to 2. So again it will print the value 2. Then it will increase the 3. Then when it goes out of this scope or local to this block, then again the default value will be set, that is your 2. So next time when increment will be called, it will print again 2. So I'm just going to execute again. You can see the output. It is printing 2, 2 and 2. So it is printing 3 times 2. Now we will see here the difference between the automatic storage class as well as static storage class. Now I'm just going to replace this auto with the static here. So I'm using here a keyword which is static in case of a static storage class. Now we will see the output again. I'm just going to execute this program it again. So just click on the save button and you will see the difference. What are the difference we are getting in this case of a static variable. So click save button and then build and run. Now you will see the output. Output is 2, 3 and 4, which is totally different from the automatic storage class. Why it is so? Let us see. Suppose this is first time we are calling this function increment. So when the control will goes to this increment to this one, so it will initialize I equal to 2. And in case of a static storage class, the default value will be 0, but the scope will be or life will be value of the variable persist between the different function called. Value of the variable will be exist between the different function call. That means every time when we will call this function, the value will be passed to the next function. So first of all, when the function increment will be called, the control will goes to this increment function. In this increment function, we are defining a static variable. That means I equal to 2. So in this case, I equal to 2, it will print here the 2 value. Now it will increase I equal to I plus 1. So it becomes here, the value becomes here 3. But when it will goes outside of this scope, that means the life of this variable will be persist between the next function call. So the value will be exist here. So when it will goes, control will goes back to this increment, the value of the I would remain there. So value of the I in the memory would be 3. Now next time increment will be called, so it will not set I equal to 2, it will just print here the value 3. Now the next time the value will be incremented to the 4, and then it will goes back to the next function call, then it will again print the 4 here, and then finally it comes out. before comes out, the value of I would be here 5. So that is the major difference between defining a variable using static storage class and automatic storage class. So let us see again the output of this program. So you can just build and run, and you can see the output, that is your 2, 3 and 4. But the same program, when we have used using the auto, it was printing here 2, 2 and 2, 3 times 2. You can see that the output again. So that is your 2, 2, 2. So that is the major difference between defining a variable using the automatic storage class and static storage class. So we come back to our last storage class. So last storage class is our external storage class. So this is fourth one, that is called external storage class. Now again we are going to distinguish each of the class using 4 parameters. So the first parameter is storage. In this case of a storage, that is memory. That means when the variable we will declare, that variable will be stored at a location which would be memory. That is your primary memory. Now default value. So in this case the default value will be 0, same as that of a static storage class. Third one, that is our scope, and the scope in this case, the global scope. That means we are going to define this variable. So this variable would be accessed within the main function, and it will be also accessed in the different functions because it is a global variable and the scope is global. Now the last one, that is your property is or feature is life. So as long as the program execution, so when the program is executing, its value will be remain, or it doesn't come out to be an end. So that will be the life. So I'm just going to write here the life here. So this is as long as program execution doesn't comes to end, doesn't come to end. So as long as your program is executing, its scope would be there. Now let us see with the help of an example program. So I'm just going to omitting this. So this is your hash include stdio.h header file. I am writing here the function void increment. Again we have taken the same function void increment. So this is your function prototype declaration. Before defining this function declaration, I can define here the variable. So how I can define the variable? With the help of integer I can define the variable. So let us see. Suppose here I am declaring variable integer I. So this is your integer I. So it becomes the global. So the scope of here the integer I is global, and this is sometimes called external variables. These are called external variables. So when we will discuss about these external variable, we have two global variables. The first one is called external variable and second is called external storage classes. So this is integer I we have declared. Void increment, I am just going to declare the another function. So this is your void decrement. Then void main function is there. This is your scope, and I'm just going to print here the value. So this is the print %d comma I. So I have printed this value of the I here because it is global. Now I'm calling the function here increment. So this is increment function calling. Again I am going to call the increment function. Now I am going to call the decrement function. So this is decrement function calling. This is another decrement function. Now I'm just going to write here the function definition of the increment. So this is increment here. So this is the scope, I equal to I plus 1. Similarly, I can write here the printf statement. So let us see how it will print on incrementing. So I am writing here on incrementing values. Then comma, for defining a particular variable we need to define %d because it is of integer type, then comma. Generally you will see when we define a particular variable in case of a main, so that variable is not accessible outside of the main function scope. But when we are going to define this external storage, external variable with the help of external variable, that means it is also a global variable. The scope of this I would be everywhere. Everywhere means we can use this I in the main function. So in this case we are going to print into the main, that means this I is accessible here. Now if we are accessing it into the increment function, this which is a local function, so it is accessible also here. Similarly, if we will going to declare the void decrement, again we are using this particular variable. So this is decrement, and you can see how it is accessing here. Suppose I am writing here I equal to I minus 1 and I am writing printf on decrement %d and finally comma I. So this I external variable, or you can say it is a global variable, its I value would be accessible in the main function as well as into the local increment function and decrement function. So just click the save button and build and execute this program. Now you will see the output here. What is the output it is printing? Default value it is taking 0, then it is printing 1, then it is printing 2, then it is printing 1, and then it is printing 0 here. So how the output is coming, let us discuss. So when we define a particular external variable, its default value it takes always 0. So before discussing about, I'm just going to taking here /n, so the output would come in an easy way. Now /n I have used, just go and then build and run. Now you can see the output. So by default it is taking 0 here, on incrementing it is 1, on incrementing 2, on decrement 1, on decrement 0. So one thing that must be keep in mind when you are going to define a particular external variable I, so its default value would be 0, and this is accessible within main function, this is accessible in the local function or everywhere during the execution of the program. Now come back to our main storage class, that is your external storage class. So how we can define this external storage class? For defining this external storage class, we use a particular keyword, and that keyword is called extern. So I'm just going to make the program with the help of external storage class. So first of all, we need to define here the header file hash include stdio.h. Then I'm going to define here a variable which is integer x, and defining the variable equal to value equal to 21. Then I am going to take here the main function. So this is your void main, then this is the scope. Then I am going to define the another variable with the help of extern, which is external storage class. This is variable y here, and then I'm just going to print here, this is the printf statement, %d comma x comma y. So before displaying or printing, I'm just going to use /n. So in this case, the x is also a global variable which is not defined during the external storage class. Y is also a global variable which is not which is defined using the external storage class. So by both the ways we can define the global variables, by which we can define the global variables which is accessible outside the main function or during the program execution. So we have not initialized the value of y here. We can initialize the value. So y equal to, I am taking 31 value. So click on the save and then execute this program. When you will execute this program, you will get some error. Why it is so giving an error? Because we cannot define here the y value. We cannot define or initialize the y value because it is an external variable. So how we can print it? With the help of y, we can define outside of this main function. So this is integer y and y equal to 31 we can display. So click on the save and then execute this program. So you can see that it is printing firstly 21, which is an global variable we have defined before the main function, and second 31 which is defining with the help of external storage class. We can also see this program because this is scope. You can see that this scope is y is also inside the main function, also outside the main function. So that is the difference between defining using the external storage class as well as your global variable. So that is the difference. We can also see the another program by which we can understood about the external storage class. So this is your hash include stdio.h. Then I am going to write here the function void increment. This is increment function prototype declaration. Now I am going to declare here the variable integer I. So this integer I is a global variable, or you can say that it is a external variable. Now this is your void main function and this is the scope of the main. In this scope of the main, I am just going to declare with the help of extern, that is your integer y variable. And finally I am going to print here, this is printf, and this is /n. I am going to declare I equal to %d and comma I, then terminator. Now I am going to call this the function increment here and then this one. Now finally I am going to define the increment here, increment, this is, and this is a scope I equal to I plus 1. Similarly y equal to y plus 4. So in this case y we have declared using the external storage class. So this y is accessible within the main or outside the main also. So it becomes the global variable and you can execute. So when you will execute, it will show you some error because it is, we have defined into the increment. And if you want to be define it outside, how we can define? Just use here integer and then y equal to like 5, then terminator, then save and then execute. So you can see the output I equal to 0. So in this case it is printing I equal to 0 and we have not printed the value of y and I. So it will not print here. So that was the program of based on the all the storage classes. That means we have total 4 storage classes. The first one is automatic storage class, second is our static storage class, third one is register storage class, and the fourth one is external storage class. So this was all about the storage class in case of a C language. So thank you for watching my videos. If you really like my videos, please subscribe to my video channel. Thank you.